Now it's time to talk about the key outcome for REFUCOAT project. I will be presenting that part. As you know, this is a European project funded by the, supported by the BBI, which is the bio-based industry entity. And next slide, Nina. REFUCOAT project started now 3 years ago. And the main idea, it was to try to solve some of the problems that already Tristan has mentioned in relation with the packaging materials. But by the other hand, we found in the way that there was something that we also could help, and it was trying to achieve the goal for the 2030 horizon in relation with the recyclable packaging structure. So we have been working on that. So our first idea, it was really in relation with the European directive. Next slide. Yeah. So here, it's as you can see, it's in the line of what Tristan has already mentioned. When we think about new packaging solution, sustainable packaging solution, we need to think about product life also, and we need to think that maybe when we are thinking or we are trying to develop new packaging material, we need to balance these two different factors. And this is based on that most of you should know that when we are thinking about bio-based polymer, we cannot compare the properties with the petrol-based material. So that could have an impact in the product cell life, and it can also have a very big impact also in the increase of food waste. Next slide, Nina. So here you can see the balance. So when we start thinking about REFUCOAT, we thought that, of course, we need to continue working in various packaging structures in order to reduce the food waste. By the other hand, we wanted also to work with bio-based materials in order to achieve new solutions that could be implemented in the packaging structures. Most of you should know that the best material for barrier packaging is the aluminum foil, which has good barrier properties for oxygen, for water vapor, and also for light. And you also know that bio-based materials could be a solution, but there could be that should improve their barrier properties and also try to be at a reduced price in order to be able to be afforded by companies. Next slide. You know. So that's why we planned to work in REFUCOAT, where we have trying to be working in developing new packaging material with 3 different ingredients. Nina, can you show the 3 ingredients? We have been trying to develop 100% bio-based packaging solution by considering also 2 different ingredients that we have by our knowledge that were really, really important, which is the barrier property and also the shelf life. So we have been trying to create like the model of the packaging for the future, for the 2030 horizon. Next slide. So we have been working in 3 different products. First product is snack, it's a chips, potatoes packaging from our partner Apex. We also have been working with packaging for breadcrumbs from our partner Daxa Group, and we also have been working with chicken packaging from our partner Manorfan. So this is the consortium. So we are 12 partners from 5 different countries, and there are 7 companies and also 5 different technological centers. Next slide. So as I told you, we have the 3 different ingredients. Now we have been focusing in what we have done in relation with the bio-based packaging. Next slide, Nina. So in the project, we have been working with PHA. So we have been trying to develop a new middle chain PHA from a low flavor byproduct from our partner Daxa. And one of our partners, in this case, Tesic and Biopolis, have been working in the fermentation of this feedstock in order to obtain the PHA middle chain, which is a polymer that is a bio-based polymer, as you could see, and also it could have a very good barrier properties for water. So it could be a solution to be used instead of polymer in some approaches. Next slide. So here, what we have been doing is trying to do blends with different material in order to be able to use this PHA in the final structures for breadcrumbs, chicken meat, for the chicken packaging. So here we have been working in obtaining compounds and also obtaining seeds to then be thermoconforming and also to be then used as a lid in the final packaging for the chicken. And meanwhile, one of the things that you can pass. So one of the things that we have been, one of the results that we have obtained, it is that we are able to obtain the PHA from the low flavor byproduct. We have found that it's quite difficult to process that material because to be able to obtain material for the different packaging, we need to obtain a material with a melting point higher than 100 degrees, and that we found that it was quite complicated. But that limitation, we try to overcome that, trying to think about different applications that where we could use that PHA, and we have been working in developing coatings based on this PHA also for packaging application. So that was in relation with the 100 bio-based polymer approach that we have been following. In relation with barrier packaging and also active packaging, we have been working in studying the degradation factor of our product, because this is the first step that we need to do when we want to select a new packaging. So when we have thought about the chips and the breadcrumbs and also the chicken, we have seen that the oxygen, water vapor, so barrier properties were very important in the case of chips and also breadcrumbs. And in the case of chicken, the most important degradation factor, it was the microorganism. So one of the things, it was that we need to select which of the main degradation factor we were going to focus our development. And in the case of the chips, we have been working in the antioxidant solution, and also for the breadcrumbs. And in the case of the chicken, we have been working in the antimicrobial solution for avoiding microorganisms. Next slide. So in relation with the barrier properties, one of the things that we have been doing in the project is working by trying to obtain a PGA, which is polymer that it's very promising because it's a very good barrier properties and also very good oxygen barrier properties. So we have been working in developing a new process, a benchmark process to obtain that material. So first step of this process has been to obtain glycolic acid from the bioethylene glycol. So that's one of the main results that we have achieved in our project. So we have been able to produce that high yield. Then our partner Fraunhofer has been working in developing the PGA polymerization reaction. That was also a very good result. So we have been able to obtain that material from a new benchmark process. And then another step where we have found more progress, it was trying to obtain a PGA and trying to hybridize it in order to improve their barrier properties. So that has been a problem, and I'm going to explain you, Ali, now why we have found a problem in that. Okay, one of the problems with the PGA is not about their production, but it's a material that is very sensitive to oxygen. So that means that they degrade in oxygen atmosphere. And apart from that, it's very difficult to dissolve in common printing solvents. So that was also a difficulty that we found meanwhile during the project execution, because the very beginning idea, it was to print the PGA coating using common printing technologies. But then we also found another way of applying that PGA, and that was a hot melt application, because this is one of the things, or one of the good key outcomes that we have been obtaining in the projects. the PGA hot melt coating that we are developing in order to be able to obtain a PGA coating for packaging applications. Next slide, Nina. Okay, and then we have the third ingredient, that is the active packaging. So because our strategy is based on, if we cannot work, if we can obtain a very high barrier properties, let's try to combine barrier properties with active substances in order to achieve a good result and alternative packaging that could be obtained from the current packaging that we have already. So here we have been working with antioxidant and antimicrobial compounds. In the case of the antioxidant, we have been working with active substances, natural active substances. All we know, because we have been doing a lot of research on that, is that we can have some organoleptic issues when we work with these active substances. But there are another materials or other compounds that doesn't have that problem with the odor. So we have been working with two different approaches. One, it was a volatile compound, and the other was not volatile, for different applications, depending on which is the kind of packaging that you are going to use. You can use volatile compounds when you have a head space, and you can have the active compounds with the volatile ingredient that can be spread in the headspace. But there are in other different packages where you need to apply different substances that act in contact. So we have been working in these two different substances, one for the chicken and another one for the breadcrumbs and the chips. Next slide. And then another thing that we have been working is with bacteriophages, which are the natural enemies of bacteria. There is a lack of research on that for packaging applications, and we have done a lot of research on that for chicken. It has been just for chicken, and we have obtained a very good result for some of the bacteria that we have tested, and this is something that one of the sessions today, one of my colleagues from INEA will talk about that. Next slide. Okay, so in relation with the active packaging, as I told you, antioxidant coating based on volatile active compound can be an option, but one of the things that we have been doing is trying to control its release by working with microencapsulation. And we also have found that not all natural substances that are approved for food contacts show organoleptic issues. We also have found that bacteriophages are new active compounds that are very interesting for future developments, and for us it has been a very positive result working with bacteriophages. But we also know that they are not listed in positive. They are not listed in the positive list for food packaging applications, so that need to invest more time and money in order to get them to get approved and to be able to have on-market solution based on them. And in relation with the different structures that we have been developing, the three different packaging solutions that we propose are based on two different approaches. We are trying, as I told you, to combine the barrier coating and also the active coating. Okay, so for example, for chips, we have been working in developing a recyclable packaging and also a compostable packaging, two different lines for two different possibilities for the end user. And in the case of breadcrumbs and for the chips, we have been working in industrial compostable packaging solution based on PLA and PHA in both cases, okay? And also all the time trying to combine the barrier property of the coating that we are developing and also the active coating of the other coating that we are developing also in the project. So our final key accounts, it is one of the most important things is that we have been working to valorize one agri-food waste that is a low flavor from one of our partners in order to obtain a biopolymer, in this case the PHA, and a middle chain PHA with improved barrier properties. one important thing is that there is not a unique solution for extending product shelf life. And if we want to talk about sustainable packaging, we need to think about sustainable active packaging, because that will help us to achieve our final goal, trying to reduce the food waste. That PDA remains a challenge, not only for us, but also for different companies that have contacted us. PDA material is a very tricky material that needs further development in order to achieve the best result, and we will continue working on that. Also that there are natural active substances that could be applied for active packaging, but of course one of the things that I didn't mention, that they are not global solution for active packaging. So that means that each substance need to be selected for each product. And another very important result, it was the results that I already have mentioned in relation with bacteriophages, that they are a promising a solution for active packaging, but need EFSA approval. And then I wanted to finish my REFUCOAT outcomes, just saying what I already have mentioned. There is not a global solution for any product that need could be customized. But if we want to think about sustainable packaging, we need to think that we cannot compare them with current materials, and we need to think that maybe we need to use different combination of materials or different solution in order to be able to achieve our final goal, that is to extend the self product life. Okay, so thank you very much.